And the reason why, if you're like, well, then how would I possibly have gotten that? Like, let's suppose you forgot that inverse tangent existed and you just found the tangent of those two things. You might get a number that is far higher, right? That is more equivalent to finding that side or something like that. Yeah?
Wait, so we just solved for the bottom one?
We did, but that's the same thing as this top one because it's a parallelogram. So if you want to, you could imagine, all right, this is 90 degrees up here, and you could actually go 180 minus 90 is 90. 90 minus 26 is what, 64, right? And then you could add up to get to 90 degrees again and find that one.
Oh.
Mason was just noticing that alternate interior angles are equal, so we don't even have to find that one, which he's right.
Okay.
Some good geometry there. Math League. Not that that's from Math League, but I'm happy that you're in Math League. All right, I'm scooting on. Yeah, I need to go back. Anybody behind? Are we good? Do you want me to put it back a little bit? Yeah. Okay. All right, now this one's getting a little tough here. Now the problems are going to start getting difficult to draw, so we've got to try our best. Okay, so we have radar stations A and B, and they're on an east-west line. So I'm going to draw east-west, just left and right line. Hello? Who? Yes. No. Yeah, sure. Okay, bye. Caitlin, they want you in the office. And if you're like, you didn't know my name, I did know your name, but she said, is Kate, it didn't sound like Caitlin, it sounded like Kaylin. And I'm like, no, don't have one of those. Okay, so it's on the east-west line, and it's radar stations A and B. Here's A, here's B, and they are 3.7 kilometers apart. How do you know that A is on the left? How do you know B is on the right? You don't. It doesn't matter. It just, my picture would be inverted if I had drawn it the other way. All right, now, radar stations A and B are an east-west line, 3.7 kilometers apart. Then station A detects a plane at C with a bearing of distance 61 degrees. All right, now, when you have a bearing, that just means from north. So we're going to draw in our north-south lines. I know it's really annoying because you're kind of used to starting like the unit circle and how the unit circle starts, my northwest line or north-south. I know you're used to looking at the unit circle, and if there's a unit circle, look up. There's a unit circle like here is 0 degrees, right? Okay, but in this case, here is 0 degrees. 0 degrees is north. Here's 90 degrees, and so on.
Cool.
I know, it goes opposite, which is very annoying. And this is for north, south, east, west, so. I know, it bothers me too, but that's just how the world works. Okay. So when it says that there is a bearing, so it's like we've got like this plane, like, I don't know, flying over here somewhere, like here's this plane in the air. And station A detects it at a bearing of 61 degrees. So that means that the angle from A to C right here is about 61 degrees. Because remember, straight up north is 0 degrees. And B also detects the same plane, only they say that it's more like 331 degrees. Okay, can you imagine it? So you have to go all the way around the circle and back to get to 331 degrees. That makes sense why it's so big? Okay? But here's the problem, is that we need to figure out what that actually is for this angle right here. So how could I figure that out? How can I, if this whole thing, this whole circle is 331 degrees, how do I find out this part, just this part?
360 minus the
Well, if I take 360 minus 331, I'll get this chunk right here.
Minus 270.
Yeah, if I take 331 and I minus 270, that'll take out that 3/4, right? So I'm gonna take 331 and subtract 270, and I find out, oh, that angle is 61 degrees. Or if you had taken 360 and minus 331, you would have found this one, and then you could have found that one. Is my picture good? Does that look like 61 degrees?
Yep.
I don't think so.
It's fine.
It's fine though. We'll work it out, okay? It'll be fine. And then, what's this angle, by the way? This one's 61 over here. What's this one?
29.
29?
Yeah.
And we know that because I drew this is just north, south, east, west, right? And those are 90 degrees from each other. Means this one's also 29 over here. You guys, 61 and 29, they add up to what? 90, which means this is actually a 90-degree triangle. I definitely didn't draw it like that, but such is life. And P.S., in case you haven't figured it out, all of these problems have right triangles in it. This section is called application of right triangles, okay? So if you're like, but how am I supposed to do this with it not being a right triangle? You didn't draw it correctly. And later, we will do triangles that are not just right triangles with the law of sines and law of cosines, which makes a lot of sense. All right, so now it says, find the distance from A to C. How far away is radar station to C? All right. We need to find out this. Looks like we've got a hypotenuse over here. Which angle do you want to tackle this from? Do you want to tackle it from the 29 or the 61? Anybody care? Somebody pick one.
29.
29. All right, we're picking 29, so that means x is adjacent to that, and c, and this over here is the hypotenuse. So we've got an a and an h. So which we use? Cosine of 29 equals ka a over h, x over the hypotenuse, which is 3.7. Cross multiply, x times 1 is x. And this part is 3.7 times the cosine of 29. Remember, this isn't a good drawing. If I had drawn it correctly, it probably would have been more like this. Okay? But I'm not going to redo my drawing because I don't care enough to redo it. What did you guys get for x? 3.2 kilometers. Now, does that make sense?
Sure.
I mean, compared to my old drawing, no, but obviously that's also not a right angle. Does that look like it's about 3.2 if the bottom's 3.7? Yeah, about. Any answer above 3.7 would be a dumb answer because the hypotenuse is the largest side of a triangle. Negative answers would certainly be stupid. 252 kilometers would definitely be dumb, okay? So keep track of the problem, make sure that you understand what's going on. How are we doing? You guys are very quiet.
I'm kind of understanding, but there's like a step in each problem that I forget every time.
That's why I picked these problems, so that we could go over them. So I specifically picked problems that I thought would be a challenge, a step up each time. This is the last one. And this one is a different way of talking about bearings. This is a specific way that they talk about bearings when they're talking about ships or airplanes. So when you're doing bearings, it starts, this is where you're looking. And this is where you then face, okay? So imagine if you were looking north and then you face 47 degrees towards the east. So I'm just going to draw a quick north, south, east, west spot for my